We are recording. So practice that sound. Let's see what we've got. That doesn't want to work. Interesting. So I'll read up the answers first, and then we'll go through any of the questions you want. And again, tomorrow we're going to do another practice test, this time individually. Monday go through that. Tuesday is the real test. Here we go. Grab your favorite red writing utensil. And here we go. Number one, what is the fundamental theorem of algebra? D. The polynomial's degree equals its total number of roots. Number two, when considering that polynomial, what result would come from the rational root theorem? That gives you the list of all possible rational roots. So it's choice C. Factors of the last over factors of the first. Number three, never mind, I scratched that one off. If anybody's really curious, the answer is B. You're not supposed to know that. Number four, that would be, yeah, that one I did not throw out. Right. Okay, good. Number four is C, quadruple vertical asymptote, although A is also a correct answer on that one. So if you got A, congratulations. I made sure there are not two correct answers on the real test. Sorry. Number five was thrown out. We didn't talk about oblique asymptotes yet. That's the next chapter. Number six, how many negative roots? D, 5 or 3 or 1. Number seven, I'm going to need to sketch that, so we'll hold tight on that. I can tell you this much. There is a hole at x equals 2. It's 2 comma something. I'll show you that on the board. There is an x-intercept at 1. And there is a y-intercept at 1/3. There's also a vertical asymptote at x equals -1. And then I'll draw that in its full glory in a minute. Number 8. Solve for this. There are 2 intervals x belongs to. Both of these are open bracket, round, 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 round. So no square brackets at all. X belongs to the interval from -5 to -1. And union the interval from 7 to 8. And a repeat so far? Of number? Yeah, number 7. Number 7. Why don't you just wait till I sketch on the board? It'd be kind of hard to get her. Yeah.
What kind of brackets were there?
Round brackets and everything for number 8. Yeah. Number 9, the big monster. Total number of roots, 7. Possible real roots, 7 or 5 or 3 or 1. Number of non-real roots, 0 or 2 or 4 or 6. Number of positive roots, 6 or 4 or 2 or 0. Possible negative roots, 1. So that's pretty much guaranteed. The possible rational roots are plus or minus 1, comma 10, comma 2, comma 5, all over plus or minus 1, comma 3. Can you read it so far? Okay. The product of the roots. Yeah, oh, they didn't even do it for me. Hang on, I gotta do this in my head. It is -10 over 3. The sum of the roots is +2. The interval on which all the real roots lie, between -10 and +10. And now getting the actual roots, there's a root at x equals 1, you're welcome. There's a root at x equals -1, you're welcome again. X equals 2, they give it to you, so I'm sure they say you're welcome. X equals, this is going to be kind of gross, I'll accept 2 different ways. Well, I'll get the 2 easier ones out of the way. X equals I, x equals -I, and then here comes the gross ones. X equals, did anybody have the plus or minus the square root of -5/3? That is correct, you just need to simplify it. It's basically radical 15 times I over 3, plus or minus. Radical 15 times I, all over 3, plus or minus, when you get the radical out of the basement. Factors, there are several variations on this, I'll accept. Let me just write this down. This is number 9 again. So it looks like this. F of x, or y, whatever you want to call it. The height multiplier should be in front, 3. Followed by x minus 2. Followed by x minus 1. Followed by x plus 1. So those are 3 of the 7 roots. Then the other 4, x minus I, x plus I, x minus radical 15. Put that in parentheses so the I doesn't look like it's in the square root. And then the other one is x plus, that thingy. There you go. So there's the factored version. However, I will accept this. The first two are the same. This, you could write it as x squared plus 1. And the other one is x squared plus 5/3. If you have that, good to go. There's one other variation you could have. X minus 2. This gives you some idea of what I do when I grade these things. And you could also have 3x squared plus 5. I'll accept that. Any of those should be fine. The one on top is the best because it's down to as small as you can go. But these are technically prime, so I will let those go. Everybody okay so far? Yeah.
When writing radical 15 times I, could you just put the I in front of the
Yes.
screen?
If you want to do, as long as the I doesn't look like it's in the radical, yeah, that's perfectly okay. And then the minus version of that. Any repeats so far? All righty. No. I see what I did. Number 10, extra space for number 9. I did not mean to number that. That was supposed to be extra. I think the computer just wouldn't give me an extra page unless I put another. That's really stupid. So there are 9 questions in that total. That is going to be what the real test looks like. So the monster one at the end is going to be, that is going to be worth more than 10 points. Just so you know. So A, so you're not going to get totally clobbered by it. And B, so yeah. I'll break it up for you. Any repeats? All right, questions, yeah.
Sorry, I have another question about where to put that I. Can
Uh-huh.
you put it like after the fraction?
Oh, you mean like this? So radical 15 over 3 and tuck the I here?
Yeah.
Yes, that's fine. Any other variations? All right. Questions? Any of those? Yeah. Number 7. That wasn't the one I was expecting yet. But yes. Actually, yeah, I sort of was. I'm just living in fear of when I have to do this one. Number 7. They'll, oh, that's right, I'm filming it. By the way, those of you at home, hi. Sorry, I just about started writing on the board and then I remembered myself. Okay, we can do this. The top is x squared minus 3x plus 2. This is for number 7. And then the bottom is negative 3x squared plus 3x plus 6. All right, let's get this out of the way. So they want you to sketch this. First thing I would do, factor the top, factor the bottom. The top factors by unfoil should be x minus 1, x minus 2. Two numbers that add up to negative 3, multiply to be positive 2. The bottom has a GCF of negative 3. If you pull that out, you're going to get x squared minus x minus 2. Make sure you switch the signs. That unfoils. So it's 3, negative 3, sorry. And then parentheses, x minus 2, x plus 1. Because that's two numbers that add up to negative 1 and multiply to be negative 2. Does that make sense so far? Okay. So when you factor that, you'll get some pieces. Roots, vertical asymptotes, whoops, that's too close. Vertical asymptotes, and possibly holes. So question, where do you look for roots? Yeah. At the top, are there any?
2 and 1.
Yeah, you set the top equal to 0. The roots are where the top, which is called the numerator by the way. Set the top equal to 0, and yeah, you'll have x equals 1 and x equals 2. Good. Nate, where do you look for vertical asymptotes?
Bottom.
The bottom. Are there any?
Yeah.
Where?
2 and 1.
X equals 2, x equals what? Negative 1. Has anybody seen anything curious? Okay.
Well, x equals 2 is negative and the vertical asymptote.
It's a root and a vertical asymptote at the same time, which cannot be the case. What is that? That's a hole. These cancel. So scratch this one off, scratch this one off. This becomes a hole. X equals 2. Does everybody see that? So this will simplify a little bit to y equals x minus 1 over negative 3 parentheses x plus 1. That'll be a little easier to graph, by the way. First of all, any questions on how we got that? That's kind of key to the next step. Now let's start putting these things in our graph. I know we have a root at x equals 1. What's another name for root, please? X-intercept. So we have an x-intercept at x equals 1. We also have a vertical asymptote at x equals negative 1. So I know that for sure so far. We also have a hole at x equals 2. So the question is, 2 comma what? You don't always have a hole on the x-axis. For plus minus notation, we just sort of write 1 on the x-axis because we don't have anything but an x-axis. 2 comma something, it could be above, could be below, I don't know. We'll find out in a little bit. Is there any other point you could get easily? I mean, you could get lots of points, but there's one point you might be able to get more easily than others. Let me think of it. Go.
0.
Whoa, be more specific.
It'll be 0, 0.
0, 0 might not be on the graph. But you're on the right track. In other words, I was wanting to know, can we get any other point that's actually on the graph? Yeah, the y-intercept. You can always get that on your own. Is it required? No, but it might help you know which way your graph is swerving. So y-intercept is, how do you find it? Katie. Welcome back. The y-intercept is found how? How do you find any y-intercept?
Oh, it's just like last term.
Sometimes. That's if you're lucky enough to just have a plain polynomial.
Yeah.
We got a mess here. Here's what we're looking at here. Think chubby hand method. All y-intercepts have something in common.
Oh, you plug in 0.
0 for x, exactly. Do it for me.
So there's negative 1
Okay.
over negative 3.
Over negative 3. So what is that really? That's 1/3. So the y-intercept is 1/3. It's a little awkward, but we can do that. Here's a 1, and I'm going to put a dot here. Just label that 1/3. That was not useless. It was a weird number, but it does tell you where the graph is swerving. Question?
Couldn't you still use the last term?
Could you use the last terms? Well, it depends. If you redistribute the 3, yes. If this is out, you might get it wrong. A lot of people say, oh, it's a negative 1 over 1, and that would not be correct. So short answer is, could you use these two? Yeah, you could. Just make sure you use both of them, one on top and one on the bottom. Yeah, because if you plug in x equals 0, all these are going to disappear. So can somebody tell me anything about what this graph is doing? Josh? Where's it going? Or can you tell me anything at all whatsoever? What's that?
It goes from the x-intercept on the right side to the 1.
Okay,
And then it goes, it's the y-intercept.
okay. So you're going backwards, good, that's a good move. And then where would it go from there?
Go towards the vertical asymptote.
Up or down?
Oh,
Why would you say up?
because if it went down, it'd be another x-intercept.
Yeah, you notice if it's doing this, it's swooping up. I can't come back down without causing an extra root that I don't want. So this is going to swoop up forever. Good. Question. Where do you think the x-intercept, or where do you think the hole is? If you had to take a guess, would it be above or below? Let's take a wild guess, just based on what you see. Nick. It's 2 comma something. Where's the hole? Above or below?
Well,
Why do you say that?
I'm guessing.
Okay. If the hole were above, what would the graph have to do to get to it? It would have to go back up and create what?
Oh, another
Another
x-intercept.
x-intercept, which we cannot allow. So the hole has pretty much got it, unless the hole is unlucky enough to be actually on the x-axis. It's a 95% chance, just without any other info whatsoever, the hole's got to be down here somewhere. It cannot be above. Question, oh math people. What kind of an asymptote is this? Single, double, triple? Mary?
A single.
Single, correct. So if it's a single asymptote, do the 2 sides swerve the same way or opposite?
The 2 sides.
In other words, if this side swoops up, will this come from below or from above?
Below.
From below, correct. Opposite side for an odd power. This is going to come from below. Question, Austin, are there any other x-intercepts on this thing whatsoever? No. Could I crash through here and go up above?
No.
No, impossible. So it's probably going to do something like that. Could it go back down? Yeah, whatever. But it cannot cross the x-axis. It can do whatever it wants down here, but it has to stay below. Now, I'm guessing that the hole is somewhere down here. I don't know for sure, but we'll figure out. It's time to find out where the hole is. Any ideas? We know it's 2 comma something. Go.
Plug in 2 into the equation.
Yes. Can I plug it in this version of the equation? Like this one? This and this are the same line.
Yeah.
There's only one problem. Before we canceled, what would happen if you plugged in x equals 2? You'd get 0 on the bottom. And right before you canceled, it would blow you sky high. In other words, if you plugged in a 2 into here, you'd actually get 0, which is a serious problem. But you can plug it into the reduced version. Go ahead and do that. So x equals 2, so y equals what?
2 minus negative 1. Minus 1.
2 minus 1 over?
Negative 3
Uh-huh.
times 2 plus 1.
Go for it.
1, 9,
1 over, almost.
negative
1 over negative 9. Negative 1/9. Right here. Can this thing, by the way, while you're at it, can it go back up?
9.
No, it cannot. I don't know where it's going to go. It could go down, it could go flat, but it cannot go back up. This, I would accept as a decent graph for the function. Does that make sense? There is one other way, if you have a few extra minutes, if you want to make absolutely sure. Try plus minus notation. Plus minus notation, keep track of the roots. There's one at 1, there's a vertical asymptote at -1, and there's a hole at x equals 2. And again, I put it on the x-axis not because I know it's on the x-axis, but because everything's on the x-axis for plus minus notation. So this is 2. I'm going to choose x equals 0, and then just run through this. X equals 0, I get a positive. For a root, single root, you tell me. Becca, if I have a positive region and I jump over a single root, will that switch? Yes. What about if I jump over a hole? It does not switch, correct. The only exception to that is if there's a war. And by the way, I will tell you ahead of time, there is no war in this chapter test. Next chapter, you might get some war, so train hard. What about over here, single vertical asymptote? It will switch, correct. This tells you that in the left-hand region, it's below. It is. In the next region between -1 and 1, it's above, and it is. Then it hits, and it does. Then it goes below, it does. And then it stays below, and it does. Now you're sure that the graph is right. Does that make sense? Alrighty. Next. I don't know which one is coming. Are you playing with my mind here? Is it okay? Okay. Okay. That was called being nice to me. All right, let's do it. Does anybody need this other stuff here? Speak now or forever hold your peace. If anybody's still writing it down. Chris, you can check YouTube later. We'll have this stuff up. Number 8 looks like x squared minus 7x minus 8. Over x squared minus 2x minus 35. And they want that to be less than 0. Quick question before I start. Sam, does this want any endpoints? No. What makes you say that?
Because it's just the less than, it's not less than or equal to.
Right. The only time I would ever use square brackets to capture some of the ends is if there's an equals here. The equals means they're asking for the endpoints. We might or might not give it to them. If it's lethal, we won't give it to them. If it's non-lethal, we'll give it to them. Why? Because we're nice people. But if they don't want endpoints, we won't give it to them. Why? Because we're nice people. Let's try this. Tell me what to do first. Megan, take over. What would you do first on this thing? What can we do? Yeah, factor. Does the top factor? Into what? Correct. X minus 8, x plus 1. Good. Let me see. Mary Claire, take the bottom. Yeah, x minus 7, x plus 5. Both of these unfoil. And this is less than 0. How do you solve a problem that's an inequality like this? Or Nicole, please. Nick. How do you solve something like this?
Find the roots.
You can find the roots, definitely. Are there any?
Yeah, 8 and -1.
What the heck am I doing? R. It's like R for root. X equals 8 and x equals what?
-1.
Good. Any other objects in there while you're at it? Vertical asymptotes, where?
7 and -5.
X equals 7, x equals -5. Questions before we go on? We all set? Make sense? Are there any holes? Josh? No, because nothing cancels. Now, Josh, take over. What are we going to do with these roots and vertical asymptotes?
Well, did you first make one, sorry, I think the name, the plus.
Are these things? Yeah, plus minus notation. So read these from left to right. What's the furthest left?
-5.
Yeah, -5. what kind of an object? Vertical asymptote. Okay, keep going. Ladies. Okay, -1 is a root.
And then 7,
7 is
vertical asymptote.
vertical asymptote,
And 8 is
and 8 is a root. Okay. I'm going to divide these up. Region A, B, C, D, E. Mary, take over.
So you can plug in 0,
Okay, what region is that?
B, well, I mean, C.
C, good save. So x equals 0. So how do you get y? I just
So
said-
like, if you plugged in 0,
Uh,
then it would be -8 and +1,
okay.
and then -7 plus 5, so it'd be negative,
Negative.
positive, negative, positive,
Positive, negative, positive. What's the final answer?
positive.
Positive, correct, because there are only 2 negatives. And keep talking me through this. Single vertical asymptote, does it switch?
Yes,
Yes. So what's the sign here?
negative,
And what's the sign here?
positive,
Good. How come?
because it's a single root.
Single root. Now go backwards. What's this?
Negative,
Yes. And this?
and then positive.
Positive, because it's a single vertical asymptote. Correct. Which regions are we interested in? Kaylee?
B and D,
Why?
it's less than 0.
Yeah, we want the regions that are less than 0. The regions that are negative. Do we want the endpoints?
No.
No, because they're not asking for them. Give me the intervals for me.
X belongs to -5, -1,
Good. What do you
round
have?
brackets,
Round brackets
and 7 to 8.
in union. And then, I'm sorry, what?
7 to 8.
From 7 to 8. And that's it. Does that make sense? Yeah.
So on the test, you wouldn't have to do a graph for that?
You do not, correct. If I specifically say graph, then yes. Although I will tell you right now, I deleted that part of the test because that's actually more chapter 3 than chapter 2. So we're going to be doing a lot of graphing next chapter, so brace yourself. For now, you can chill a little bit. Any other questions on this? Think you could do that on a test? Go ahead, hit me. I've been in suspense long enough. Questions? Oh, you people are funny. Why? No, we're fine. Yes,
So for number 8, you don't have to graph it?
correct. Number 8, you do not have to graph it. Yeah, we changed that. I gave you a worksheet where I had you change this to y. In this particular one, you do not have to graph it. Just plus minus notation is a graph, but it's a condensed graph. That's all you need. You can definitely graph it if you want, but I think it would take more time than you need. By the way, as an advertisement for this, anytime you want to solve an inequality, you have to graph somehow. But it doesn't have to be a full graph. It could be what we call a compressed graph, which is another name for plus minus notation. Honestly, nobody wants number 9. Thank you. The other shoe is finally falling. All right, number 9. Can you tell me which parts? Because there are like 9 parts, I think. What is it? 5, 6, 7, 8, 9. Actually, 11 parts. So, on that list, any of those that you would have trouble with? Solving it. Okay. Let's try it. First of all, is everybody okay with finding the pieces? The intervals, the positive roots, negative roots, real roots, non-real roots, possible rational roots, etc. Is everybody feeling okay on those? Those, by the way, are meant to reduce the number of guesses you need to try. All right. Can somebody do me a favor and read this thing out? It's huge. So, blah, 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 blah equals 0. Can somebody do the blah, blah? Actually, Kitty, help me out. Read that big monster off.
3x up to 7
Okay.
minus 6x to 6
Okay. plus 10 equals 0. Is that right?
Yeah.
Okay.
And the root is
And the root is 2. So they gave you a free root, x equals 2. I'm curious if anybody spotted it. Yeah.
factor it by group.
This thing factors by grouping. You can do that right away. You do not have to. I'll do that in a minute because it is kind of exciting to have a factor by grouping with 4 pairs. What you end up with is kind of weird. You have to factor that by grouping. But just for snorts and giggles, try the root they gave. Josh, take over. What if you tried the root? How do you rip it out?
Sorry, you
Synthetically divide. So you've got 2, and then 3, negative 6, 5, negative 10, negative 3, 6, negative 5, 10. Does everybody see why factoring by grouping would work on this, by the way? Why? Think about it.
Because there's an even number and they're proportional.
Yeah, there's an even number of terms, and they're proportional to each other. Multiply by negative 2, multiply by negative 2, multiply by negative 2, multiply by negative 2. They're proportional. So, can somebody run me through this first rip out root? Austin, take over.
So number 0, 0 and 3,
Uh-huh,
and then I'm multiplying that by 2, so it's 6,
uh-huh.
and 0,
Yep.
0, and 5,
I need people paying attention here. Go ahead.
5,
5, keep going.
and then 10,
Uh-huh,
and 0,
yep,
and then 0,
yep,
and then negative 3,
uh-huh,
then negative 6,
yep,
and then 0,
yep.
and then 0, and negative 10,
Negative,
negative 10.
not yet.
Oh,
Add.
oh, negative 5,
Negative 5,
and then a negative
say
10,
negative 10, and then
0.
yes. Is everybody right so far? This is successful, so we know that x equals 2 is a root, although they promised us anyway. Can somebody translate, Nate, take over, translate this for me.
So it's 3x plus 6,
Yes, plus,
0x to the fifth,
yep, hang on a second, plus 0x to the 5th,
5x to the fourth,
5x to the 4th, plus,
0x plus square root,
yeah, plus,
3x squared,
uh-huh,
and 0x.
0x plus negative 5. Now, the condensed version of this is this. 3x to the 6th plus 5x to the 4th plus negative 3x squared plus negative 5. Would there be any advantage in writing it like that? Katie?
You could, factor it by grouping.
You can factor this by grouping. Do it.
Well, actually, 4.
Yeah, so x to the 4th, and what's left behind?
3x, third, plus 5,
Good. Keep going.
and pull out negative 1.
Negative 1. Good.
And 3x squared plus 5.
Good. Does this work? Do it.
So we'll just do 1 x to the 4th plus negative 1
Uh-huh.
plus 0.
X squared plus 5. Yeah. And then this is x to the 4th minus 1, basically. Can anybody do anything else with that? Mary Claire?
X to the 4th minus 1.
What method works with that?
Difference
Difference 2 squares. What does it break into? Is- Yeah, x squared plus 1, x squared minus 1. Does anything else factor while you're at it? Right. Into what? X plus 1, x minus 1. And this is x squared plus 1, and this is 3x squared plus 5. How do you know when you're done factoring? Question is, how do you know when you're done factoring? When all the terms on the bottom are prime. You can go further. If you just get all the roots, you can just do parentheses, 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 x minus the first, x minus the second, x minus the third. So if you have roots of like 1, 2, 3, 4, 5, 6, you'd have x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6. You can do that no matter what root. If you have negative 1, negative 2, negative 3, x minus negative 1, x minus negative 2, x minus negative 3, which we call x plus. Or, if you're doing it by hand, you do not have to factor this into x plus I, x minus I, although it does do that. You can leave it because it's prime. So the question is, how many roots are buried in here, Becca? Total.
6.
6. What makes you say that?
Because the first two can be, solved. Well.
Like, how many roots are in this first one?
2.
2, exactly. And then how many in here? 2 in here. 1 and 1. That makes 6. Where's the 7th?
That's 2.
That's x equals 2. Correct. So we've got, what parentheses would that have come from? If you reinflate it? X minus 2. So if you do this, by the way, you notice there's a 3 in front? You have to include it somewhere. What I normally do is 3 and then 6 parentheses. But you could, remember, it's already here. If you use these, you may. Just be aware that this doesn't have a 3 in front of it. This is x minus 2. So if you factor it out, you should have x minus 2, 3x squared plus 5, x squared plus 1, x plus 1, x minus 1. And that's done. I will accept that as the final answer for your factoring part. Solving. How do you solve? Let's set it equal to 0. What would you get here?
-1.
-1? How about here?
1.
Good. Whoops, positive 1. And then I'm going to put these up here separately. X squared plus 1 equals 0, and 3x squared plus 5 equals 0. Do this one first, if you would.
3x squared equals -5.
Good. Keep going.
X squared equals -5/3.
Good. Divide by 3. X squared is -5/3. Keep going.
And x equals square root of -5/3.
How many answers?
2.
2. Plus or minus the square root of -5/3. There's 2 problems with leaving it like that. Let's get this down forward. What's wrong with leaving it like that?
There's a radical in the basement,
Radical in the basement?
and it's a square root of negative.
Square root of a negative. How do you fix that? Take over Nick. How do you fix square root of -5/3?
Something with an I,
What is I?
imaginary number.
Right. And what's its value?
-1 squared, no, radical -1.
Radical -1. If I is radical -1, you should be able to split that off. So right now, this is plus or minus radical -5 over radical 3. So where's the I?
-5.
Yes. Split it off. X equals plus or minus square root of,
I radical, no.
well, 2 radicals. What's the nice part?
-1.
-1 times
5.
5. Correct. And this is radical 3. What is this really?
I,
This is I. Now get the radical out of the basement.
multiplied by 3, radical 3.
Radical 3, where?
On the top and bottom.
Top and bottom. What's radical 5 times radical 3?
Radical 15.
Yep. Times what? I, all over.
3.
Radical 3 times radical 3 is 3. There are your 2 roots there. Does that make sense? All right. Megan, take over. Solve this thing for me. X squared plus 1 equals 0.
Subtract 1.
Okay, so x squared equals,
-1.
good.
So it would be x equals plus or minus I.
Yes, that is x equals plus or minus I, and you're done with that one. So 2 roots, 4 roots, 5, 6, 7. Done. Questions? Yeah.
So you said something about like you put the 3 in front when you're factoring,
Oh, okay.
but then you didn't.
Right, I didn't, partially because it's already in here. How would you know it's already in there? If you get all 6 parentheses, it probably won't be in there, you probably have to add it in. Here's what I mean. If you get all 6 roots, let's just say, if I do this, the first one is, actually you tell me, Mary, what parentheses would this come from?
X minus 2.
Yeah, so x minus 2. Do the next roots. There's 1 and -1. So what would those be?
X minus 1, X plus 1.
Correct. And now, do the i's.
X plus I, X minus I.
Good. X plus I, X minus I. And then, Josh, take over. What are the last two parentheses if you use these monsters? It's easy to do, just hard to write.
Do you want like plus and minus or like separate?
Separate.
So we just do radical 15 times I,
Over
3.
3. And then do what with it? Because when we had a root of 1, we did x minus 1. When we had a root of 2, we did x minus 2.
So it'd be x minus radical 15
Right. X minus radical 15, parentheses,
times
I, all over.
3.
Now do the other one.
So it'd be x plus.
Plus.
15
Radical
times
15, I over 3. So the question, your question, Mary, do you see any 3 in front of any of those parentheses yet? That's when, I know there had to be a 3 in front, and there isn't yet. That's when you manually add that in here. If you already factored it by hand and there is a 3 in front, you don't have to worry about it, it's already in there. So if I put a 3 in front right now, it would actually be wrong, because it would turn into a 9 in front. That'd be way too big. Yeah.
What if you factored out the 3x squared plus 5 to get those two parentheses, but
Like
then you
these?
didn't with x squared plus 1?
Oh, I see. If you had, oh, I see what you're saying. If you got this and this,
But you kept x squared plus 1.
oh, then if it would, well, let's just try it. That means it would look like this. Like that? So do you see any 3 in front of any of the terms? No, then you have to manually add it in. Okay, does that make sense?
Yeah, thank you.
No problem. Any other questions on this monster? All righty. That was faster than I thought it was gonna be. Are there any questions on the first page? I want to give you one more practice problem. If you'd be so kind and take out your notes. I want to give you one more practice problem in graphing these things, especially if there are holes. People find holes to be kind of challenging. And next chapter, we're going to get some tools to make our graphs even more accurate. We're kind of fast and loose in chapter 2, which is totally okay. They're approximately okay. Y equals x cubed minus 6x squared minus 4x plus 24. Hang on. Yeah. Actually, hey, let's be creative. There you go. I would like you to graph this thing. This will be the last problem today. Somebody tell me where I even start.
Key factor,
Mm-hmm. Take it back.
top one,
Top part? How would you factor that?
grouping,
Grouping. First of all, I would add the opposite anytime you get the chains. What comes out of the first pair?
x squared,
Good. What's left behind?
x minus 6,
X minus 6. Yeah. You can also do x plus negative 6. I don't care. Plus what?
negative 4,
Negative 4, parentheses what?
x minus 6.
X minus 6. Good. Because if you pull a negative, it switches the sign. Is this working?
Yeah,
So what do you get?
x minus 6,
Uh-huh.
parentheses,
X squared minus 4. Is that factor? Sam, take over.
The x plus 2x minus 2,
Correct. What method was that again?
difference of 2 squared.
Difference of 2 squares, correct. Keep going while you're at it, Sam. What about the bottom? Is it factored all? unfoil works with degree 2.
Yeah.
There's something y'all should check for first.
Oh, you do, well, I guess you do GCF of X.
Yes, there is a GCF. So X, and then what's left over if you pull out the X?
X squared
Oh.
plus negative 8x plus 12.
Correct. So, Nick, take over. Does this factor
Yes.
into what?
X.
Well,
That's all going.
I'm sorry, you're what going on?
Myself, and my back.
Yeah, you do know you're not supposed to have that with you, correct?
Okay, yeah, sorry about that.
Keep going.
Can I just shut it off if it's still?
That would be wise. If it's your mom, say hi for me.
Okay, I will.
I got a story to tell you about that in a minute. Go ahead.
So that's, I have up to be negative 8,
Correct. And multiplied by
negative 12, and
positive 12. Look at the positive 12, that might be easier. What two numbers multiplied by 12?
2 and 6.
2 and 6. And what kind of numbers would it be?
Negative 2 and negative 6.
Correct. Is everybody okay with this so far? So we got this thingy. How do we graph it? Becca, take over.
What do you think, like, roots and polynomials?
Yes. Where are the roots?
X equals 6.
Uh-huh.
At the top, sorry.
Okay.
Equals 6. And
Sorry, I should write these down first. Holes. Actually, I would put a piece of advice out. Are there any holes? Let's catch those first. Where?
X minus 2.
At x, so that's x equals what?
Oh, X equals 2.
X equals positive 2. There's a hole. Any others?
No. Wait, yes.
Yes, where?
X equals 6.
Whoops, I forgot the x. Sorry. X equals 6. Relatively exciting. So are there any roots?
Yes.
Where?
X equals negative 2.
Good. And then vertical asymptotes? It's boring, but it's there. Out in front.
X equals 0.
X equals 0, very good. Because x is really secretly x minus 0, if that makes sense. So, we've got 2 holes, 1 root, 1 vertical asymptote. You may use any tools at your disposal. Your knowledge of what the graph normally looks like, you can use plus minus notation, you can find an x-intercept, well, you got x-intercepts. You could try and find a y-intercept, etc. Somebody help me out. Where do you start? Is there anything you can nail down at this very instant? Go.
You can put down the roots and the vertical asymptotes.
Yeah, where's the root?
Negative 2.
-2. At least I can get an x-intercept at -2. Okay, what else?
And vertical asymptote at x equals 0.
A vertical asymptote at x equals 0. Quick question. Where's the y-intercept? There isn't one. Why? Yeah, the vertical asymptote is running over it and killed it. So there is no, unfortunately, we cannot do the y-intercept trick. So I have no idea whether this is going up or going down. Question?
If you plug in negative 2, would it come out to 0?
Yes, it would. Correct. As a matter of fact, we can try it real fast. Can somebody give me the simplified version of this mess here? What's the only things that survived? Actually, Nate, go ahead.
X plus 2 over x.
Correct. That's where you plug into. And sure enough, -2 will give you 0. Can anybody find anything else? Yeah.
You can mark where the holes are.
We can mark where the holes are. First of all, what are the 2x values of the holes?
2 and 6.
2 and 6. So 2 comma something and 6 comma something. Can you find the height for the 2 comma something?
You can plug in a 2.
Yes. Plug it in where?
The simplified version.
Simplified version. Do it. So y equals,
4 over 2 should be 2.
yeah, it's 2 plus 2 over 2, which is 4 over 2, which is 2. Congratulations, you just found your first hole. It's 2, 2. Make sure it's open. Sam, find the other hole height. How do you do it?
Plug in 6.
Yeah, plug in the 6. What do you get?
6 plus 2 over 6, which is 8 over 6.
Uh-huh. Which reduces to?
4 over 3.
4 over 3, which is 1 1/3. So the height on that is 6, this is 2. 6 comma 4/3 is basically 1 1/3, which is over here. That should tell you something. It does give you a direction where the graph is going. So, Megan, if I were to hop onto this hole and run backwards, I'm aiming toward the asymptote. It can't crash in. Which way does it swerve? It has to swerve up. Why? Right, if it swerved down, it'd cross the x-axis and make another route. So this has to swerve up. Correct. This would probably, can this ever go down below 0? No, that would make another route. It could go up, could go flip-floppy, I don't care, as long as it doesn't go down. Can anybody tell me what happens on the other side in the last 45 seconds we have? Sam. This, what kind of an asymptote? Single, double, triple?
Single.
Single. And a single asymptote, do the two sides swerve the same way or opposite ways? Opposite. So if this swerved up, where's it going to reappear? From below. What's it going to do?
Or wait, sorry, it goes through it.
It goes right through it. Why? Yeah, it's an x-intercept, and single, double, or triple? Single. A triple route would swerve it. And then last but not least, would it ever go back down? No. I don't know where it's going to go. It might go up, it might flatten out. Who cares? As long as it doesn't go back down, good to go. Make sense? All right, we're out of time. So tomorrow, practice test number 2, you're going to be doing it alone. So let's see what happens. We're going to do the novena one more time. Let us pray. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Hail and blessed be the hour and moment in which the Son of God was born of the most pure Virgin Mary, at midnight in Bethlehem, in piercing cold. In that hour, vouchsafe, O my God, to hear my prayer and grant my desires, through the merits of our Savior, Jesus Christ, and of his blessed Mother. Amen. In the name of the Father, the Son, and the Holy Spirit. Alrighty, see y'all later. People at home, cheerio.